If you're using Skyzone goggles and you're using the 18650 battery pack, I'm off to a good start already. The low battery alarm happens way too soon. I found a mod on the internet that shows how to solve that problem, and I decided to take a slightly different approach to it. Here's the mod, here's the schematic that they're talking about. And what he explains is that this is a simple voltage divider network. All right, that would be negative. Up here would be positive. There's a resistor and a resistor. And if the resistors were identical, the voltage in the middle would be exactly half of the supply voltage. If you vary the value of the resistors, then my screen went blank. It's going to keep doing that, darn it. Then you can alter the voltage at this point. The voltage at this point is what is being detected by the goggles, converting it to digital. It's an analog to digital converter, and showing you the bar graph on the screen. So online, the gentleman was talking about replacing this resistor. He shows you a picture of which resistor to replace. However, my version of Skyzone Sky02 3D goggles, the board looks different than the photograph he shows. So I basically went through and checked out the components, found the ones that are in the same orientation, and this is the location that the resistor is in. I'm going to supply photographs to show a little bit better. So before you get too excited about altering your voltage detection threshold, you're going to have to be really good at fine soldering. I used a soldering iron about yay big, some fine tools, a lot of magnification, and this is the component that I removed. I'm not so sure this thing is focusing right, but it is extremely tiny. It's like my son described it as a pencil point. So I couldn't find the exact resistor I needed. In the diagram, he shows 82K. I don't want to order a bunch of 82K resistors in bulk. 82K, actually, I'm sorry, this is the default value, 82K. He recommends around 75, somewhere around 75K, maybe 70K. So what I did was I ordered these. They came in a really interesting pack. I think it's pretty cool. This envelope is printed directly on, and the envelope is made out of folded heavy cardstock, and it's sewn shut. And inside, wrapped in bubble wrap, was this, and I think it's scented, either that or the very heavy smokers in there. And I ordered like a 5-pack of these very fine trim resistors. This is 100K, so I'm going to use the trim resistor instead. And the way I did this, I'm going to be moving things out of the way. And again, look at how small that thing is. That's a little speck. You got to be able to desolder that from the board. So what I'm going to do is I'm going to attach the pot, and I did right here, attach the pot to the circuit board so that if you do have to disassemble it, the pot will come with it because you have to solder wires onto it. So I'm basically making it part of this board. To adjust it from outside, I drilled this hole right about in this spot. So the way I implemented this is you put this in place where it belongs. Everything is small, by the way. Okay, and then put the screw in there. attach it, mark where the screw hits the case. Then find a drill bit just slightly, ever so slightly bigger than the adjustment on the end. See how it sticks out there? Drill the hole on a slight angle because the bottom is sloping, so you need to drill at about that sort of an angle right there. All right, fit it all together. Put something in there, hold it up against there, and put a little dab of epoxy right there. Just hold it in place. Stay away from the screw. And wait until that sets up real good. Then remove it and finish your epoxy job on the other side. And if you do a good job with the epoxy, it'll stay on there pretty good. You do not want to get it anywhere near this mounting stud in here because I had a little spillover, and fortunately I removed it before the epoxy completely cured, and that would have been permanently fused in there. So I picked these two particular pins on the pot. The ones together, I'm going to join together on one side. You don't have to, but I'm going to do that. And then the other ones stand alone. So that's my connection. The center and the one you're seeing to the right is what you want to connect it to. If you adjust the pot clockwise, it's going to raise the scale on the display, and counterclockwise, it's going to lower it. And when it goes counterclockwise, it actually lowers the ohms. When you go clockwise, it raises the ohms. That's my theory anyway, and I'm sticking to it. This is the schematic that I traced out from, a little bit more light there, that might help. This is the schematic I traced out on my version of the goggles because that board is different than the photo that I saw online. And this is not a perfect diagram, and if you look, the target resistor is 76K. That's the value that you want to end up with, and it caused me a bit of confusion, but I removed it anyway. Fortunately, it's kind of away from other resistors, so it's maybe a little bit easier to remove than one that has one right next to it. But 76K is supposed to be what I'm supposed to set it to, and it's supposed to what I was looking for, the resistor I was looking for in my trying to find this one on a schematic, the 82K, to verify I was in the right place. Came up as 76K, but when I removed it from the board, it was actually 82K. So that's close enough. That's the resistor that I wanted. So again, that's the circuit. So what I'm going to do now is I'm going to mount it and solder these leads to it, not necessarily in that order. I'm going to do some adjustments and try it out. A word of caution. And it's the same caution that the originator of this design mentioned. This value here brings positive voltage, more positive voltage to this midpoint. If you lower that too low, even though there's a 1K series resistor going to the analog to digital converter, if you make that too low and it goes above 3.3 volts at this point, you're going to burn that converter out. Now I found out that I can alter this by a pretty good amount before the voltage is going to get high. I found that out by using the formula that he posted online. It's pretty cool. Put it in a spreadsheet and you can throw in different numbers and come up with what kind of variations you can provide in your pot and still make it safe. So I'm going to come back with the next part of this video after I'm further along. Oh, by the way, what I did before I started this project was I wanted to find out what voltages actually I did need for my Skyzone to convert to the scale properly once I made my adjustment. I use this Toolkit RCM8. I use the output function, and I rigged up a cable here so that it plugs into the Skyzone, and I can plug this into the output. It's handy to have adapters, XT60 male to male, XT60 female to female, so you can do all kinds of crazy projects like this one right here. Followed all the way up, and that's how I discharge my batteries. If I need to test the current of them, I can alter how many ohms this thing is by moving the jumper to different positions on the coil. This is 8 ohms. It's a heater element. It's an electric heater, 120 volt heater or 240. I'm not too sure what the original voltage was. Anyway, I digress. I connected this to the output of the M8 and adjusted the M8, and I observed the scale on the goggles in the display to get an idea on how much voltage, what voltage point alarms and what voltage point shows full. I wrote all that stuff down so I'm better prepared when I start making changes to the goggles. Again, don't ruin your goggles on my count. I'm not finished with this yet. I'm not so sure it's going to work right, but I guess I'm going to find out sooner or later. One little side note. Look at how messy my desktop is here. This is what a hobbyist desktop should look like. If it's all pretty and clean, that's a professional video blogger. But if you're building something, if you got drones, this is what your desktop looks like, and don't be ashamed of it. Just clear it off once in a while like I do. So here I finished the soldering. I put a little bit of liquid electrical tape on there in case for some reason it does cut loose and flops around in there. I don't want it to touch anything. The idea of this is adjust it once and leave it alone. Oh, by the way, here's the handy video of where the snap tabs are. If you're going to remove this, that's where the general positions are. So I had to take these back apart. They were working good. Snap the top on. I had no video on either one of the displays. So what I found out was that these ribbon cables got caught by these and put a nasty indentation in one of the cables. It also ripped them right out of the connector. So I hope this thing's going to work when I power it back up again. So be very cautious. I don't know how well you can see this, but the way I left the resistor after installation, 8.4, which is going to be the maximum voltage of the 18650s times 2, is full. And at 7.2, the indicator on the screen is displaying half. At 6.8, we're hitting the yellow. And then at 6.7, we get an alarm. That's about 3.3 volts per cell. That's borderline if you're using a LiPo, but it's a 1.7 volt spread. However, here's the rub, and I didn't consider this until just now. This is the operating range of the goggles right here. So it doesn't want to go any lower than 7. Ideally, you can get the best spread for voltage and the longest running time if you had, where at? I don't have it on here. Yeah, 3S. Look at the difference on the voltage range. You can start at 12.6 volts and go down to 10.9 volts before you get an alarm. So that is a 1.7 volt spread. What I had before on 2S with the 18650s is a 1.1 volt drop. So 1.7 is pretty good. I think I was shooting for 1.8 with these 18650s, but I think I'm going to go back in and readjust it to a higher level, because it may not, even though the goggles are operating at these lower voltages, it may not be good for them. I don't know if you can see this, but this is 8.4 volts. Here comes 7.6 volts. Seven 7.2 should be yellow. And then we're going to go 7.1, and we should hear some beeping. Okay, I'm all done. This is the final setting that I have. These are the final voltages that you saw. These are the adjustments I made to achieve that from the original starting value of 75K. Funny thing is, my guesstimate puts it only 1K off from what the factory resistance range was. With that being said, I also don't know whether that analog to digital converter will get an overvoltage condition with this modification if you should decide to go up to higher voltages like 26 volts. I calculated in allowing for 3S. I know that won't exceed the junction by a great margin. I don't know what additional voltage will push it over the edge and maybe put out 3.3 volts to the analog to digital converter, which would definitely cause a problem according to the guy that originally started this idea. So I'm going to go back and show you the adjustment. I'm going to scooch back here and show you the way my board was laid out and the way your board might look. And last final warning is, do this at your own risk.